Determine the first four terms of each sequence given the formula for a sub n. Recall that a sequence is simply a list of terms. Looking at the notes below, the sequence is a sub 1, comma a sub 2, comma a sub 3, comma a sub 4, and so on. Notice here the first term is a sub 1. Some sources give the first term as a sub 0. If we are given the formula for a sub n, to determine any of the terms, we simply substitute the value of n in the formula. For number 1, we have a sub n equals 49 minus n squared. We want to determine a sub 1, which is the first term in the sequence. To do this, we substitute 1 for n. A sub 1 equals 49 minus the square of 1. The square of 1 is equal to 1, and 49 minus 1 equals 48. A sub 1, the first term of the sequence, equals 48. To determine a sub 2, we now substitute 2 for n. A sub 2 equals 49 minus the square of 2. Square of 2 is 4, and 49 minus 4 is equal to 45. The second term of the sequence is 45. To determine a sub 3, we substitute 3 for n. A sub 3 equals 49 minus the square of 3. 3 squared is 9. 49 minus 9 equals 40. To determine a sub 4, we substitute 4 for n. A sub 4 equals 49 minus the square of 4. The square of 4 is 16. 49 minus 16 equals 33. The first four terms of the sequence are 48, 45, 40, 33. For number 2, a sub n equals 13 plus the quantity n minus 5 times 3. To determine a sub 1, we substitute 1 for n. A sub 1 equals 13 plus, notice inside the parentheses, we have 1 minus 5, which is negative 4, and then times 3. Following the order of operations, we multiply before we add. Negative 4 times 3 is negative 12. 13 plus negative 12 equals positive 1. To determine a sub 2, we substitute 2 for n. A sub 2 equals 13 plus, inside the parentheses, we now have 2 minus 5, which is negative 3, and then times 3. Negative 3 times 3 is negative 9. 13 plus negative 9 equals positive 4. To determine a sub 3, we substitute 3 for n. A sub 3 equals 13 plus, inside the parentheses, we have 3 minus 5, which is negative 2, and then times 3. Negative 2 times 3 is negative 6, and 13 plus negative 6 equals positive 7. To determine a sub 4, we substitute 4 for n. A sub 4 equals 13 plus, inside the parentheses, 4 minus 5 is negative 1, and then times 3. Simplifying, we have 13 plus negative 3, which equals positive 10. For number 3, we have a sub n equals 3n divided by the sum of n and 10. To determine a sub 1, we substitute 1 for n, giving us the product of 3 and 1 divided by the sum of 1 and 10. Simplifying, we have 3/11ths. For this sequence, if the fractions do simplify, we would need to do so. To determine a sub 2, we substitute 2 for n, giving us the product of 3 and 2 divided by the sum of 2 and 10. 3 times 2 is 6. 2 plus 10 is 12, giving us 6/12ths, which is equal to 1/2. To determine a sub 3, we now substitute 3 for n. A sub 3 equals the product of 3 and 3 divided by the sum of 3 and 10. Simplifying, we have 9/13ths. To determine a sub 4, we substitute 4 for n. A sub 4 equals the product of 3 and 4 divided by the sum of 4 and 10. Simplifying, we have 12/14ths. 12 and 14 share a common factor of 2. A sub 4 simplifies to 6/7ths. And for the last example, we have a sub n equals 2 times the nth power of 3. To determine a sub 1, we substitute 1 for n. A sub 1 equals 2 times 3 to the first power. Following the order of operations, we evaluate the exponents first. 3 to the first is 3, giving us 2 times 3, which equals 6. To determine a sub 2, we substitute 2 for n. A sub 2 equals 2 times the square of 3. Square of 3 is 9, and 2 times 9 is 18. A sub 3 equals 2 times the cube of 3. The cube of 3 is equal to 3 times 3 times 3, or 27, and 2 times 27 equals 54. And finally, to determine a sub 4, we substitute 4 for n. A sub 4 equals 2 times the fourth power of 3. 3 to the fourth is equal to 81, and 2 times 81 equals 162. I hope you found this helpful.